The next talk is Coding for Curiosity from our beloved returning speaker, John Sundell. So please welcome and enjoy the talk.
Cool, thank you very much. All right, hi everybody. It's so great to be back here in Oslo in the mobile era for the second time. I was here for the very first year and couldn't make it last year, so it's really great to be back. So my name is John Sundell. I'm an iOS developer, and I also run Swift by Sundell, which is a weekly blog and podcast about Swift development. And today, I am super excited to be here to talk to you about one of my favorite kind of pet topics, and that is how we can use curiosity as kind of a fuel to drive our development process, our learning process, our personal growth, and how we can use it to perform a lot of different experiments and learn new technologies. So the talk is called Coding for Curiosity, and in it I want to give you my top tips how I use curiosity in these kind of ways. So let's dive right in. This is the comfort zone. It's an area that all of us enter and leave multiple times per day, depending on the tasks that we work on and depending on which people we work with or in which context we might be in the comfort zone or outside of it. And what kind of governs the comfort zone is what governs kind of the area and the border of it is a lot coming down to our experience. And here I'm not talking so much about how many years of iOS development experience do you have. I'm more talking about what kind of technologies you have worked with, what kind of problems you've faced in the past, and kind of what technologies and techniques that you feel comfortable with. Now, I'm a developer, so whenever I have something in real life, a concept or something like that, I always like to find some way to model it in code. And I think a good way to kind of model the comfort zone is as a pure function. Now, functional programmers, they're always talking about pure functions, right? Functions that always give you the same output given a certain input. So they are predictable, because if we give an input A to this function, we always know that we're going to get the same value of B out from it. So it's predictable, we know how it works, and it's kind of comfortable. We can find comfort in this fact that it's going to always behave the same way. And if we think about it, it works the same way for us when it comes to our experience building certain things in iOS. For example, if someone would come to you tomorrow and ask you to build a list, you pretty much know that it's a pure function from a list to a table view, because you have probably used UI table view 100 times before, you know how it works, you feel comfortable with it, so when someone asks you to build a list, you know which tool you need to use, and it's all kind of very comfortable, and we know how it works. And I think this phenomenon, this kind of pure function phenomenon when it comes to how we work with our experience and that we feel comfortable with the things we know, I think that's a big reason why we as developers tend to find silver bullets and tend to use technologies as silver bullets. Because if we think about it, a technology that is seen as a silver bullet is kind of a technology that we apply to all sorts of problems, even those that are kind of outside of the domain that the technology was designed for. And these can be things like protocols or protocol extensions, or even things like value types or frameworks like RX Swift or something like that. You know, they all have a really great use case, but if we start treating them as silver bullets and we apply them everywhere, things can kind of go wrong quite quickly. And I think a big reason why we do this is just because these technologies feel familiar to us and they're comfortable. So we tend to view technologies as silver bullets and just apply them everywhere, where maybe finding an alternative solution that is more geared to that specific use case would have maybe been a better solution. So today, let's try to step out of the comfort zone. And I want to talk about 3 different ways that I use the power of curiosity to step out of my personal comfort zone, to improve my code, to learn new things, and to find new solutions. So let's dive right in and start talking about the first thing, which is how I believe that we can use curiosity to increase the overall quality of the day-to-day code that we write. So the fact of the matter is that when we do development and we write software, things are not perfect. You know, things are not always the way they are in the documentation, or the way they are in a conference talk, or the way they are in a blog post. They are sometimes a bit messy, and sometimes we end up having code in our code base that is a little bit awkward. And that is just a product of reality, and it's probably always going to be that way, that we have some code that is a little bit awkward. And that's fine. But sometimes it's awkward, but we're kind of used to it. It's still awkward, but we've kind of gotten to the point where we've written it so many times that we kind of just feel like, well, that's just the way things have always been. That's the way things are. So let's just stick with it, even if it's not perfect, even if it kind of has some problems. So I want to show you some concrete examples. Let's say that we're building a profile view controller. And this view controller here follows a very standard pattern of having some kind of subview. In this case, it's a header view, and it's an optional. Because we've learned over the years that Apple have always recommended us that we should not set up our UI in the initializer. We should set it up in view.didLoad. So whenever view.didLoad gets called, then we create our header view, and we assign it to our optional property. Looking just at this code here, everything is fine. There's nothing really wrong. There's no problems. But as I'm sure all of you know, is that once we start actually using this property, things become awkward quite quickly. And so here we have a new method called configure for user, where we're actually setting up this header view for a given user model. And here comes the awkward part. We have to always constantly unwrap this optional, even though it's actually required by our program logic. Our profile view controller wouldn't actually work without its header, but it's still an optional, and we have to unwrap it, even though we kind of know as a developer that it's there. And then we might start making assumptions, we might start using force unwrapping, and then things get kind of messy very quickly. And what's even worse is that we can even go ahead and comment out this assignment to this property. We can comment out the creation of this header view, and the compiler won't tell us about it. So things still work, things compile, but then if we might have like a force unwrap somewhere, our app will start crashing. So this is not ideal, it's kind of awkward. And what we're essentially dealing with here is a concept that I like to call non-optional optionals. And it's even so good that it has if you take the first letters of non-optional optionals, it even spells no! So it really tells us that we shouldn't be using these, right? So there's a couple of different ways to react when you have a problem like this. One way you can react is what I like to call the boring answer, which is, well, that's just the way Swift works. You know, it just has optionals. It's just a fact of life. We're using Objective-C under the hood, which UIKit is written in. The translation is not perfect, so that's just the way things have always been, and that's the way things will always be. Well, I think there's also a curious answer, which is that there needs to be a better way to do this. It can't be that this is the ultimate way to do things, and we should be able to find some other solution. And the cool thing here is that if we just start to become a little bit more curious and we start looking maybe into the Swift language itself, we can actually start finding some new techniques that we could use that actually ends up solving this problem for us. In this case, we can use a technique called lazy properties. And lazy properties is essentially a way to do exactly what we want to do, which is delayed initialization. So now we can go back to our profile view controller, we can update our header view to use a lazy property instead of using just a regular one, and that way the first time it gets accessed, in this case when we configure with a user, the header view gets created lazily at that point, and we can then use it. The benefit is that we're still conforming to the standard of not creating the UI up front for a view controller. We're still following the platform guidelines, but we're also getting much nicer code that we can write in a nicer fashion. And the cool thing is that lazy properties is something we can use for so many different problems whenever we need to create something on demand instead of creating it up front. So we talked about the non-optional optionals letter combination no before. I want to talk about another letter combination. And I think this is the one that most people here are aware of. And it's MVC. Or like it stands for, Massive View Controllers, right? Well, this is a joke that you hear all the time. That whenever you write an MVC app, we always end up with massive view controllers. There's no way to make it testable. There's no way to make it nice. You always end up with these view controllers with thousands and thousands of lines of code, and it's always a problem, right? Something that many, many iOS developers are struggling with. So why is that? Well, if we think about it again, if we have this profile view controller that we wrote before, the implementation that you saw earlier was extremely simple. It just had one header view, we just assigned some properties on it, and that was it. So we might start out simple with each of our view controllers and have really good intentions. Our view controller might just be managing views and doing some layout and maybe handling some events from the user. But then things start to grow, and we might need to implement new features, we might implement new requirements in this profile view controller, and we might start adding things like networking and model decoding and caching, and then things grow a little bit. And then we add navigation and error handling and integrating with the system, and all of a sudden our view controller is so big, it's really hard to deal with, and it all just falls apart into one big unmaintainable mess. The boring answer is that's just the way MVC works, right? It's always been this way, and it will always be this way in the future. And the curious answer is there needs to be a better way, right? And if we think about it, if we go back here to this list, we look at this profile view controller, what are some of the things that we could actually move out of this view controller? Why does this view controller need to do all these different tasks? I assure you that if you go into Apple's developer guides and you start reading about their version of MVC, there's nowhere in this guide where it says view controllers should do everything. You know, it's not there, but we still tend to do that because it's convenient, it's something we used before, it's very comfortable. I think that if we look at this list, I think these are some of the things that we could actually move out of our view controller. If we think about it, a view controller is a controller for a view, so it makes sense that it manages views, and it also makes sense for it to integrate with the system, because so many of the APIs that we use as iOS developers, whether it's rotation, handling keyboard events, or other things, are done on the view controller level. So these two things, it makes sense for a view controller to do, but all of the other things we can actually quite easily move out. I want to show you a couple of examples. Let's say we're talking about layout. How can you move layout out of a view controller? Well, the easiest way to do it is just to create a custom view instead. That way, when we get the call to load view, we can actually just assign the view property with our own custom view. We could move all of our layout code into a profile view class and then just assign it. And the cool thing is, if we do it this way, we can still leverage all of the defaults that view controllers have with sizing that view, managing the lifecycle of it. We've just taken control of it, but we can still leverage the system for everything else. But if we don't have that capability right now, let's say we don't want to create a new subclass of UI view, or it's not possible to just move this code, we could do it incrementally. We could create something like a view configurator, which is just an object that is just a root class, and it just has a method for configuring any UI view for the profile use case. And this could involve something like adding the labels, adding the constraints, maybe setting the right font, and things like that. And then we could gradually move our layout code into this object so that we can make the view controller contain less of this code. Next, what about navigation? Well, there's a lot of different ways we can solve that as well. The view controller does not need to be the one pushing new view controllers onto the navigation stack. For example, we could use the coordinator pattern, which is becoming really popular in the iOS community, where instead of having the view controller do all those things like the navigation logic, we instead offload that to a coordinator which coordinates multiple view controllers. So we call the coordinator and we say, hey, the messages button was just tapped in the UI, can you please react accordingly? And then the coordinator can be the one to push the right view controller onto the navigation stack. But if we don't want to use coordinators, and maybe we don't have like a linear flow, which coordinators are great for, we might need another abstraction. Like for example, we could implement a navigator, where we have a navigator that gets injected into our view controller, and then we have an enum that defines different destinations that this navigator can navigate to. So we can just call it and say, hey, navigator, can you please navigate to the messages screen? And that way, the navigator can contain all of that logic, and we can, again, offload things from our view controller. Now finally, what about networking? This is something that I see so many view controllers have. They have this networking, they have call to URL session or API client or things like that. But there's also an easy way that we can offload that into other objects as well. We could, for example, create view models where we have the view model itself load its own data and then notify the view controller when it's done. And then the view controller can render that, and then it can call the view model to get the data that it needs. But if we don't want to switch to like a MVVM style pattern, we could stick with MVC, and we can actually create other types of controllers, like for example, logic controllers, where we just take all the logic from the view controller and move it into another object that just acts as the brains behind the operation. So we just have a method called load that gets called with a handler that gives the view controller the model that it needs, and then it can just render that. So there's so many different ways that we can actually move things from view controllers out into other objects. We can use things like child view controllers to compose multiple view controllers together. We could separate our data source objects for UI table view and UI collection view into separate objects as well. We can use the presentation pattern or the factory pattern. There are so many things that we can do. But I think that really the key here, like the key learning, is that if we stay curious and we try out new patterns and new techniques and new abstractions and don't accept the things that they will always remain the way they've always been, is that this is where we can actually improve our code. Because this will all give us enough tools in our toolbox to pick the right abstraction for the right situation. So we're no longer dealing with silver bullet style solutions, and we're no longer just accepting the problems that have been, but instead try to improve things as we go. So that is number one, trying to improve the quality of our code through curiosity. Next, let's talk about how we can use curiosity to fuel our learning process. Now, I think that I don't have to convince you in this room that learning is good. Well, after all, you're in a conference, right? You're trying to learn new technologies, trying to learn new ideas, and learn from the experience of other people. But the problem is that we can't go to conferences every day, right? Learning takes a lot of time. We always have to do work, you know? We can't just learn all the time unless we're in school, maybe. This is when we could learn all the time. So how can we find a way to incorporate learning into our day-to-day development process? This kind of becomes the challenge. Well, if you think about it, development is not a straight line. No one is expecting us to always just move in a straight line without any problems. We're always just delivering exactly when we said we were going to deliver something. We always have the perfect estimates. We always never run into any problems. That usually doesn't happen. The development line usually doesn't look like this. It more looks like this, right? We have these normal moments where we're just working on our code and everything is just normal, and we're building table views, building buttons, and it's all just normal development. But then we have these valleys where we get really frustrated, Playgrounds doesn't work, or Xcode doesn't work, it's continuously crashing, how are we going to solve this problem? But then afterwards, we have this really high energy, we're super excited, we just figured out the bug, we just figured out that if we have an empty playground inside of the workspace, then everything just magically works, We figured out these kind of tricks, right? So these moments are awesome. But the problem is really here in this kind of area, where we're starting to transition from the day-to-day normal work into something that's frustrating. And this point in time is when most developers will react the exact same way. Let's say you figured out that there's a problem in the code, you don't really know what's going on, you don't really know if the API is working the way it's supposed to, so what do? Stack Overflow.com, right? That's the very, very common answer. And I love Stack Overflow. I think it's an extremely valuable resource, and I use it all the time. But I think that there's something here to be said for challenging yourself to maybe not always go to Stack Overflow, but instead seeing this as a learning opportunity. It can be really difficult to do in the heat of the moment when you just want to solve a problem, but it can really be super valuable. So what I'm talking about here is what I like to call offline coding. It's a little bit like pretending like you're on a plane. And even though if you're in the office with a gigabit internet and really, really fast, you can always access Stack Overflow, to try to imagine like you didn't have an internet connection, you don't have access to Stack Overflow, how would you solve problems? So when faced with a problem, whether it's an unpredictable behavior in UIKit or something in Swift that doesn't really work the way you're supposed to, it doesn't compile, you can't figure out why this associated type won't let you use the protocol. So before we search the internet, before we jump onto Stack Overflow, and before we just find the answer, before we skip to the last chapter of the book and find out who lived and who died in the story, let's try to do some things before and try to make this into a learning experience. So what are some things that I do? I want to give you 3 examples of things that I usually do before I jump into Stack Overflow. The first thing I usually do is I go to the documentation. I know, I'm old-fashioned. I go to the documentation. Apple's documentation gets a lot of kind of criticism for sometimes not being up to date. Sometimes it documents the title property as the title, right? That's very useful. But a lot of the times it's actually pretty great. We've got really good documentation for a lot of the core fundamental technologies. They give you lots of overviews and they give you the story of why you're supposed to use this API. And they also, most importantly, give you the important notes of when are you supposed to subclass this class, when are you not supposed to do it, when are you supposed to become the delegate and not. And just having a little bit of patience to reading this documentation can be really valuable because you're learning so much more about the platform and the APIs that you use. You don't only learn about exactly the code you're supposed to copy and paste from Stack Overflow, but rather you learn about how the APIs actually work under the hood. Speaking of under the hood, sometimes the documentation doesn't give you all the answers you need, and you need to dive a little bit deeper. And for this, now I'm going to get even more old school, I like to use header files. For those of you who weren't around for the Objective-C days, you might look at me like, header files? What is this guy talking about? Well, header files used to be this thing we had to write in Objective-C, but they're still around because guess what? All of the APIs that we get from Apple are all still in Objective-C. They're just like nicely masked to look like Swift. And the cool thing is that in Xcode, we can get access to any header file that we actually want. We can't read the source code for most of the thing, but we can read the header file. So how do we do that? Well, if we open the quick open dialog in Xcode and type any class that we're interested in, for example, UI view, we can actually jump to the header file. This gives us full access to the actual header. And the cool thing here, even though this is in the ancient language of Objective-C, it gives us a lot of valuable information. First of all, we can see all the different properties, all the different methods that this class has, which can give us a clue to what we want to do. But this is what I really love about header files, all the comments. There are so many comments here that actually don't show up in the documentation that we can find as hints to see how the things work under the hood, which can give us a better understanding of how we're supposed to use something. But here's an even cooler thing. So if you don't like Objective-C, I don't blame you. You know, we all love Swift, right? You can go to the quick open dialog, you can click this button here, this little Swift logo. What that will give you is that when you open the header files, you actually see the translated version of it into Swift. And that is great because you get a much nicer overview, it's more simple, it's easier to read. The downside is that you lose the comments, so I still recommend that you check out both the Objective-C version and the Swift one, but this one can be great if you just want a quick overview of a class to see how things work. Now the final thing that I usually do before jumping onto Stack Overflow is I do some debugging. Now, debugging, of course, is something we do every single day, but debugging can be a very useful tool for learning also how things work under the hood. So here are some tips of how I usually debug things. Let's take a use case of where I have a view that doesn't get rendered correctly on the screen. Let's say that I expect it to have a certain frame, but it just doesn't show up. Like I just can't see it on the screen. The first thing I usually do is that I print out the view. That will show me the frame of the view so I can see maybe it has a 0 frame, maybe it just is off screen for some reason, so it gives me a good indication. I can also look at the constraints. Oh, sorry about that, a little bit fast there. And I can actually see what constraints I've applied to this view, which can also give me a hint of why it is not rendering correctly. Finally, this is a nice little trick, is that I can look at the siblings of that view by accessing the superview subviews. And that way I can see if perhaps my view is covered by another view. But the cool thing is that in the debugger, in LLDB, we can even run Swift code. So using the expression command, we can actually color the view with a red background color, or run any other expression that we want, which actually gives us an ability to do code injection right here in the debugger, so we can try out different things. There's also a very common area of ending up with memory leaks, and you might not know why. So you can also use the debugger to get the retain count for a certain variable. For example, in my view, I might want to check how many actual object is retaining this object. And finally, if I want to see all the different variables that are available in the current frame of execution, I can use frame variable. And that way I can see lots of interesting information about what values are currently available to me. So these are just some of the tips of how you can use LLDB in a more powerful way to gain more understanding before jumping onto Stack Overflow. If all these three things fail, then I do go and search for it. So it's definitely something that shouldn't be avoided at all costs, but doing these things before can really, really be valuable. So that is offline coding. What it's all about is about trying to learn more about the tools and platforms that we use every day and trying to stay curious to do that. And to also give a great opportunity to improve our debugging and problem-solving skills. By doing this, instead of just, again, looking up the answer, we can really get into a habit of learning more things and just improving our overall skills. And for me, who travels a lot, this also has a really, really great benefit of not having any internet. For example, if I'm actually on a plane, it's not a problem because I can still code because I'm not used to just always having to use Stack Overflow. So that is the second chapter of how we can use curiosity to fuel our learning process. Finally, let's talk about how we can use curiosity to build something that at first might seem to be an impossible task. So in the beginning of this talk, I talked about the comfort zone and how it contains the things that we are comfortable with and we know how to use. Now for most iOS developers, probably most of us here in this room, those contain things like building apps in the first place, doing UI development, maybe some animation code, requesting the network, handling databases, and things like that. These are tasks that we have to do for almost every single app that we work on. And we might not always use the most advanced aspect of these things. We might not be like really into databases and do the most advanced queries, or we have the most complicated networking stack, but we kind of know how these things tend to work. But on the other hand, there are some aspects of software development that can be really, really far away from our comfort zone. For example, if I asked you to, can you please go ahead and build a compiler? How would you feel about that? Or how would you feel about building your own debugger? Something that would feel comfortable? Is that a pure function? Probably not. Lots of side effects, probably. And how about building a really advanced editor with lots of different functionality? That would also feel kind of not very comfortable. Or how building a complete IDE, like basically building our own version of Xcode? Is that possible? Is that possible for something for us to do as mere mortals? Right? Is that something that we could go home and do today or tomorrow? Could we build our own compiler, our own debugger, or our own editor or IDE? Is that something that we could do as, developers? Well, I want to tell you a little secret about these four things, about compilers and debuggers and IDEs. You know what they are? These four things, are just programs. They're just software, which means that if we are software developers, we can build these things. They're all made 100% out of code. There is no real magic sauce involved here. It's just about the comfort and the experience. And if we want to gain this kind of experience, if we want to try to build something like a compiler or like an editor, the only thing we really have to do is we just have to start out simple. We have to try to not envision the most advanced thing in the world, but to rather start out with the initial building blocks, to break down the problem into separate pieces and attack them separately. And I want to show you two examples of doing just that. Let's start by building a compiler. That might sound crazy, right? I have about 15 minutes left, so you might sound like, can we build a compiler in this amount of time? Well, if you think about building a compiler for Swift, probably not. It's probably going to take a little bit more than 15 minutes. But let's say that we want to start out simple. We just want to learn how a compiler works, what goes into building one, and try to demystify this thing. Well, we could build a compiler for an extremely simple language, a language that looks like this, that only really has two features. The only thing you can do in this language is that you can set the value of a property and you can print the value of a property. That's the only two things you can do in this language. So that's something that we could actually tackle and we can use it as a learning thing. So let's do just that. Let's build a compiler for this language. The first thing we're going to do is we're going to define what the output of our compiler is going to be. What's a program? And in this case, a program for us is just going to be a Swift closure. So we want to take our source code and compile it into a Swift closure that we can then execute in our Swift code. And to do that, we're going to write a compile function that takes a string of code and then either throws an error or outputs a fully working program. So let's start implementing this function. The first thing we're going to need to do is we're going to need some states. Just like any other thing, we need some states. So we need a way to keep track of the different values of all of our symbols. So that's a dictionary from the symbol name to the value. And since we're just dealing with strings in this language, we can just keep them as strings. And our output is just going to be an array of strings that we can then, at the end of the program, just output. To actually start parsing our code, and this is where the learning starts kicking in, we realize, okay, the first thing we need to do to write a compiler is actually to do parsing, or lexing as it's called. And the way to do this in this language is simply to split the string by new lines, because every instruction in our language is on a new line, and then start iterating through it. To do that, we're going to use Swift's enumerated API to get access to both the line and the actual file, the actual line and the actual index of that line. And then we're going to call another function that we call compileLine, where we give the line that we want to compile, we increment the index by 1 to get the line number, and then we also pass the symbol values and the output collections into this function. Now, if you haven't seen the syntax before, this ampersand is basically passing a value type by reference. So we want to be able to modify these collections inside of this compileLine function, so we pass them by reference instead of passing them by value. Now, once we've compiled each line in our program, the only thing we need to do at the end is simply to return a closure that prints all of the output joined by a new line separator. And that way we're going to get all of our print statements printed out on the command line. All right, so now let's dive a little bit deeper and look at the compileLine function instead. How does that look? Well, like we saw before, it takes a line to compile, it takes the number of that line, and then it takes the symbol values and the output as in-out parameters. The same thing we do here, we do lexing or parsing, where we actually split the line up into the only delimiter that our language currently supports, which is an equal sign. And then we get the components. We can assume that the first symbol is always going to be the first component. Like the first component is always going to be the symbol, because we are either going to print it or we're going to assign to it. And to determine whether we're dealing with an assignment or a print, we're going to just switch on the number of components in this array. If it's one component, it means that we have an output. So what we do then is that we just verify that we don't have an empty symbol, because that means that we have a new line. We want to just skip those. If we can't find the value in the symbols value dictionary, we can actually throw a compiler error. And we can say that, hey, we have a missing symbol here. We haven't found the symbol before, and here's the line number. So we give a really nice compilation error there. Otherwise, we just put the output into the array, and we're done. For the assignment, it's even easier. We just take the second component from the array and assign it into our symbol values dictionary for that symbol name. And then, if we have another count of components, it means that we actually have a compilation error. So we throw an error that we have an invalid syntax, and here's the line, and here's the line number. And that's it. We've now written a compiler. I think that's pretty amazing. And the cool thing now is that we can take this code that we originally had, the greeting hello world, we can invoke our compiler onto it, and then we get a program that we can run. And then we get hello world back. Now, you might criticize this compiler for a number of reasons. You might say, that's not useful. Who would ever use a programming language like this? It's not useful for anything. It doesn't even have higher order functions. It can't be useful, right? Well, I think it's really useful to do these things because it demystifies the aspect of a compiler. So the next time we might have a compiler error in Swift that we don't understand, if we keep pulling this thread and we keep kind of learning more about how compilers work and realize that they're just normal software, we might be able to actually dive in and take a look and learn more about that. And that can be really, really helpful in many different situations. So that's how we can get started building a compiler. What about a code editor? What about actually an editor that we can use to write code? Well, again, when you think about, just like when we thought about a compiler, our mind immediately jumped to doing something like a Swift compiler or maybe a C++ compiler. When we jump to thinking about a code editor, our minds will usually jump to things that we're familiar with. Like building an editor, it sounds like building Xcode. That's probably going to take hundreds of people for 10 years, and we still might have an app like Xcode that, well, it works most of the time, right? Well, an editor doesn't have to be as complex as Xcode. Again, we can start out simple just to use it as a learning opportunity to learn more about the tools that we use. So we can build an editor that looks like this, which is not as feature complete as Xcode, but lets us type in code, it has syntax highlighting, and we can just do it for fun. So how can we do this? Well, the cool thing is that if we build this as a Mac app, we actually don't have to do much at all, because the Mac platform is so incredibly powerful and it provides so many things out of the box. For this editor here, all we really need is 3 classes. We just need NSDocument, which is what macOS uses to manage a document that we edit. We just need an NSWindow to actually render the window that we use. And we just need an NSTextView to render the actual text that we want to write, the text field that we want to use for writing our code. So let's break this down and let's talk about each of these components and what it would include to build something like this. Well, the NSWindow, let's start with that. That's actually the easiest part. You see this really cool dark window appearance? I did a prototype editor like a month or so ago, and a lot of people replied and said, "Wow, John, that's a really cool design. How did you do this cool design?" And I was like, I just did 1 line of code. Window.appearance, NSAppearance, vibrant dark. That's all we need, and we get this super cool looking window. I think, again, this just shows the power of the Mac platform, that it is so mature and has so many tools that doing something like this, which looks really cool, is incredibly simple. And the same thing is true for NSTextView. It involves a little bit more code to set it up for the code purpose, but it's still definitely doable. So how will we configure this NSTextView to work for writing code? Well, the first thing we need to do is we just need to disable some built-in features of NSTextView. You see, NSTextView is essentially taking the text edit app on the Mac and just giving you a class that is this thing. Like it's the full text edit experience, but as one view that you can use in your app. So we need to disable some stuff. First of all, we want to remove the background color just to make it clear so we can see our beautiful window underneath. And then we need to remove the automatic substitution of quotes and text replacement because we don't want the autocomplete to kick in when we're trying to write our class names. Then we want to do syntax highlighting. For this, there's a bunch of different open source libraries that we can use. I actually wrote one called Splash, where the only thing we need to do to get syntax highlighting is to import one of these frameworks and configure it, like what font we want to use, what theme we want to use, and what kind of syntax highlighter we want to use. And then we just assign ourselves as a delegate of the text view, so we get events whenever the text changes. And whenever the text does change, we just compute a new string based on highlighting it using the syntax highlighter, and then we assign that back to the text view's text storage. And that's all we need to do to create an NSTextView for code editing, which I think is pretty mind-blowing. Finally, let's talk about documents and how we can use NSDocument to load and save our code. This might sound like something that's extremely complex, but it's really, really trivial. If you've tried to do something like this on iOS, it usually involves a lot of different code and dealing with databases and things like that. But on the Mac, we just have to implement 2 methods. We just have to implement one method for writing to a file, which is you just return data of a type, and you can just UTF-8 encode your code and just return that as data. By the way, this is a really cool trick for returning a non-optional data, just using the UTF property of a string and then jumping that into the data initializer. And then when reading from a file, we can just get the data and turn that into a string. That's all we have to do, and the Mac takes care of the rest for us. We get open save dialogues for free, we get versioning, we get all that kind of stuff just by using NSDocument. And just like that, we've actually built a simple but a fully working editor for code. And I think that is pretty cool. So building the impossible, it really becomes possible if we start out simple and if we start breaking down our problems into smaller pieces. We might not be able to build a compiler for Swift, we might not be able to build the next Xcode, but we can start out simple and learn. And this can be extremely valuable to learn more about the tools that we use, how they work, and to experiment with different ideas. So, to summarize, by being curious about alternative solutions to a problem, we can gradually increase the quality of our code. Hopefully not increase the problems, decrease the problems. And this is what we talked about in the beginning. By not accepting the solutions that we've always used as the ones that we're always going to use, but instead trying out new things and challenging the norm can lead us to some really interesting new patterns and some interesting new techniques. And if you also use curiosity to fuel our learning process, it can help us discover so many new techniques and help us master our tools more quickly. If we don't directly jump onto Stack Overflow, the first sign of problem, we just jump onto Stack Overflow. If we instead try to figure things out ourselves, we actually teach ourselves more about the underlying system and the language and tools that we use every single day. And finally, if we keep staying curious, it can really let us build something that might first seem to be completely impossible by breaking down really hard problems into simpler parts. You can learn more about things like Mac development or building a compiler or designing a language, and this can be really, really empowering. So I hope that this talk has inspired you to start using more curiosity in your day-to-day workflow, to try to step out of your comfort zone every once in a while, and to try to build something that at first might seem impossible. And that is coding for curiosity. Thank you very much.